Sorry for the delay. So my presentation is Joint Deep Learning, a novel framework for urban land cover and land use classification. So my name is Zhang, lecturer in Geospatial Data Science at Lancaster University and jointly with UK Center for Ecology and Hydrology. So basically, I want to talk about urban analytics background. So there are huge complexity in urban environment. As you can see, this picture captures all kinds of different activities and complexity within that space. And there are increasing population and human activities around the world. So together with ever-growing volume of sensor data captured in this space, there are huge opportunities for Earth observation, such as satellite image, aerial photograph, even UAV drones or ground sensors. As you can see, these are a kind of satellite image or aerial photograph of an urban area. So it's really something that's interesting within that space. There are lots of development in the past. I'll have to say this work was part of this work was with Autumn Survey, and basically 95% in Autumn Survey they do manual interpretation, and there are some development in machine learning, such as supervised learning, unsupervised learning. So they all follow a standard process of from data to information to insight, and then generate some actionable knowledge. So passing from describe the data, discover the pattern, and predict the certain patterns and prescribe what kind of things it is. So the machine learning is a great way of easing the manual interpretation process. But it's not a real solution because it's always too simple to represent reality. So there are lots of development in the past, especially in AI, big data, deep learning. So there are lots of things happening in the geospatial space. As you can see that big data, geospatial data, and AI, it seems like there's something can transfer current things. So really, we were looking at deep learning in urban remote sensing. So when I do a sort of word cloud, so basically this is something come out within that space. As you can see that they have remote sensing image, convolutional neural network, classification, recognition, feature recognition, those kind of things. Mainly, the classification is the first task and the most important task in urban remote sensing. This is urban land cover and land use classification, which I think is the first thing that needs to be solved. Basically, urban land cover and land use is in different form. So urban land cover is described as physical properties of a land surface, such as including land cover such as buildings of different roof tiles, asphalt road or tarmac, woodland, grassland, and water, those kind of categories. These are called land cover. And if you talk about land cover change or modification, so normally from forest, if it didn't change, it's intact forest. If it degraded forest or into grassland. So in terms of urban land use, it's more about the purpose and activities, so by which humans are using the land. So in terms of broad land use, they have residential area, commercial area, industry, parking lots, recreational area, those kind of things. And there are specific land use, such as supermarket, shopping mall, cafe. Those are categories of land use. And in terms of land use change or land management purposes, so it's more related to some area which is undeveloped area transition into park or industry or residential. So these are difference between land cover and land use. There are lots of work. So recently in deep learning in land cover and land use, I give some examples. In terms of land cover classification on the left, you can see 2019 they did climate zone related land cover classification, and Zhang 2018 they did some semantic segmentation of different land cover types. So, and those are the land cover classification using deep learning. And on the right side, these are the land use classification work. That's in 2018, Zhang developed the object-based convolutional neural network for land use classification, and Huang developed the skeleton-based convolutional neural network for land use classification. So in this work, we were looking at, because in the previous work, all of them are doing separately, either land cover classification or land use classification. So the innovative here is developing a joint deep learning framework between land cover and land use. Actually, in the classification hierarchy, they can go even high order functions, such as railway stations or different kinds of supermarket. Those are even higher land use. So in this work, we focus on land use and land cover, this basic simple classification hierarchy. So this is one satellite image, and on the right side is the land cover classification. It classifies into grassland, tree, shadow, water, those kind of land covers, and on the below is land use classification, classified into transportation, low density residential, high density residential, commercial, those kind of land use classification. So joint deep learning framework would classify these two classification in a single framework. So basically, let me describe the joint deep learning framework. It basically involves a pixel-based land cover classification of multilayer perception. So traditional MLP multilayer perception, and that's for land cover classification. And for land use classification, it is for using a newly developed object-based convolutional neural network on the below. So in the framework, so when you enter in the land cover sample and land use sample, so it would first use MLP multilayer perception to derive the land cover classification, and based on this land cover conditional probability or probabilities that enter into object-based CN to classify the land use, and then from this land use enter into the MRP and an original image. It classifies again for the land cover and land use in an iterative way. So from first iteration to nth iteration, it converge. So it's really modeling those land cover and land use relationship and strengthen this through reinforcement learning process. So this is a remote sensing environment I published in 2019. So look at land cover and land use classification in a single framework, and you can see that the over accuracy is increasing for both land cover and land use, and around iteration 10, it's starting to converge, and seems like land cover reaches 90% accuracy around, and land use reached 86 or 87% of accuracy. So later I developed further for this work to incorporate skill sequence, which is from minimum skill to maximum skill, and in each processing scheme, they use the different skills. So that's entering the skill sequence into this framework, and you can see that the comparison in these two study area, Bournemouth and Southampton in UK, you can see that with 5 iteration, the skill sequence is steady, and the original joint deep learning needs about 10 iteration. So it's really reducing the time of iterations in terms of convergence. So here we further develop this work using the generative adversary network. So it's mainly for generating some samples, and then with this object-based CN, so it generates patch-based samples, and with pixel MRP it generates pixel samples. It's I think the key thing is it reduces the requirement of a sample size among this framework. So you can see that in the table, if it's 100% samples enter in, so the cross count is still good accuracy in terms of land cover and land use. So if you reduce the sample size in 50%, the cross count is really good in comparison with previous framework like joint deep learning or skill sequence joint deep learning. And even in 30%, it still represents higher accuracy in terms of land cover and land use. So it's really reducing the sample size requirement in terms of this joint framework. So you can see that in the classification result, it's also improved in terms of accuracy. So our future work is further develop this cross-GAN. So within the joint deep learning framework, we're looking at improving the accuracy, computational compute efficiency, and sample size requirement. Also looking for generalized method into even wider urban area and different space, and incorporating other socioeconomic data for urban dynamic modeling, but also looking at, for example, if an area has mixed land use, so using socioeconomic data like CDRC data could improve accuracy in terms of classification and modeling. So eventually we want to develop the urban digital twins that replicate the digital earth of urban area, so for smart cities and citizens. So if you have any suggestions, please contact me and we'll be in touch. Questions?
Thank you, Xi. Very interesting. So for those of you who were here yesterday, you already know the drill, but for those who weren't, if you start typing questions into the chat, I appreciate it takes some time to type in there. We've got plenty of time for questions, so the next talk is not until 10 o'clock, so we've got plenty of time for discussion. So I can maybe start off with a question of my own. So on your last slide, you talked about using 100%, 50% and 30% sample of data. How did you choose that sample? Was it randomly across the study area, or did you take out?
The sample is from polygon, and then split the polygon into 60% of training and 40% of testing. And within the 60% training, so I randomly generate those samples.
So I'm just wondering what the impact is, say, if you had, I think you talked about 2 cities, Southampton and what was it?
Yeah.
Bournemouth, yeah. So say if you had the data for Bournemouth and you tested it on Southampton and vice versa, how do you think the model?
Basically, this model is not designed for generalization at the moment. But if you're thinking about transfer learning, such as fine tuning, so if you have some samples entering into the model, you have to train it. Otherwise, if you directly using the model trained in Southampton, it won't work in other places. Does it make sense?
Okay. How do you think you might tackle that in the future?
So in terms of generalization, I think there should be some development in the space in transfer learning. So that's the way of dealing with this.
Okay, thanks for that. So we got some questions coming through in the chat. So
yeah.
first question from Ahmad. What is the deep learning framework used here? Did you use TensorFlow or Keras or others?
It's based on TensorFlow Keras. Keras TensorFlow. TensorFlow is the back end of that. Okay. Yeah. Keras TensorFlow.
Okay, so another question. If you can't hear me very well, then you can read them directly from the chat. But how does the cross-scan method differ or improve upon the JDL method from a technical point of view? So in JDL, it's claimed that MLP and object CNN is trained simultaneously, where in fact they're trained in series. Is the cross-scan method different to JDL in this regard?
I think it's MLP and object specification is the basis, and with that we generate samples, and that's the key thing is cross-scan can reduce those samples requirement. Okay.
Okay, so the final question that we have on here, what's the spatial resolution of the images you're using for the object-based segmentation, and do you think these methods would work on Sentinel-2 images?
This is dealing with what I did here is using the 50 centimeter and 25 centimeter aerial photograph. So in terms of Sentinel-2 image, so I think it will work. Depends on sort of what kind of classification system you're looking at. So in terms of Sentinel-2, you've got 10 meter or 20 meter resolution, so you can looking at land cover and land use. I think you can work. It will work with this resolution.
Okay, so we've still got a few more minutes for questions if people want to keep putting those in the chat. So we've got another one here. So where did you get the data and labels for the roof tiles that were identified in the land cover data?
This was basically a combination of mostly from the Ordnance Survey. They've got master map, but what I did here is using some other sources like OpenStreetMap and other things to determine what kind of roof it is, and even looking at Google Earth. So it's difficult to find the source of those roof tile, but if you have some training samples, it would work with this method.
So are there any instances where you think that, so if you're not 100% sure about the ground truth data, what do you think the effect would be on your model? So if you're predicting labels that are not actually correct?
Yes, the training sample could be uncertain, but what I did here is double check the training samples. always. So when you randomly generate samples, always looking through what kind of training samples you generate. Because it's consistent in this within class and between classes is it different. So that's the key thing, is looking at the training samples you generate.
Okay, so another question through that's related to sample size. So did you create the vector data and corresponding mask as a training data set, and what sample size do you think is enough?
So what I did is using the vector data of polygon and randomly generate point data within that vector data, and that point data is the center of convolution neural network. So, and the patch center is the point of your generator. So the sample size requirement, I think for each class, you have to got a few hundred samples at least. So in terms of cross-scan, I found that within each class, if it's less than 200 samples, the accuracy start to lower. So it certainly needs some samples, but not too much. In terms of traditional computer vision, they need 100,000 samples. So in remote sensing, we tend to use less samples than computer vision.
Okay, and there's another question just on the method of training and testing. So maybe you could just reiterate how you did the training testing.
Training and testing. The most important validation was conducted on the data to measure the accuracy. Can you is your question about how I generate training and testing samples or validation samples or not? I'm not 100% get your point. What was
maybe we can wait for that participant to confirm in the chat about that one, to maybe add some more details. In the meantime, I just wanted to ask you about the partnership with Ordnance Survey and how this research could be used in practice by them.
Yeah, it's basically we've developed a knowledge transfer program. This was done. 80% of this work was done with Ordnance Survey in my PhD. So and it's and at the moment we're trying to create some impact through a EPRCRC impact acceleration account, and that's knowledge transfer to Ordnance Survey. So I think at the moment Ordnance Survey is starting to use this joint deep learning framework already, and they were still testing the accuracy in terms of parameter settings and how to generalize into wider space across UK, Great Britain. So I think there's a way to do further. Okay.
Yeah, that's really good. The impact acceleration account is a really good way to make sure that you get good impact from your PhD. So I wish you best of luck with that. So I think maybe because we've got a couple of minutes left, so the guest, I don't know who they were asking about the training and testing. So could you just maybe just go through that procedure again?
I think what I did here is because in terms of training and testing, you need some randomness within that. So it's sort of like reshuffling between training and testing. So what I did is k-fold, 5-fold cross validation between them to make sure that your validation is more objective. So is that what you ask? I still don't get it.